Okay, if Bryan and the rest of the Watershed Council team want to join us, we're going to get started, and I'm hoping that you guys can see my screen share here. Well, just to kick us off, my name is, I'm getting a text. I'm hoping that doesn't mean she sees my notes. Let's see. Okay. You might be able to see my notes. I apologize for that, but my name is Andrea Coronado. I'm Development and Communications Director for TIP of the Mitt Watershed Council, and I'll be facilitating today's Icebreaker Speaker Series. We have about 100 registrants joining us today, so when we get to the Q&A portion of this program, we may have to limit questions to keep our presentations to an hour. I want to thank you for joining us today. We'll be hosting this Thursday, every other Thursday at noon through March, and I hope you join us again. The Icebreaker Series is free to our community thanks to our generous members and donors. I'm sure many of you are in there today, in our audience today, and I just thank you so much for your support. For those of you who are new to the Watershed Council, we are an environmental membership-based nonprofit celebrating 45 years this year of protecting and caring for our water resources in northern Michigan. And with the help of many, we work to preserve the truly irreplaceable lakes, streams, and waters that make northern Michigan so unique. We work locally in watersheds within Antrim, Charlevoix, Sheboygan, and Emmett counties, and throughout the Great Lakes Basin. So just a little bit of housekeeping today. We will have all attendees muted during the program to avoid any background noises. Just a warning, if I'm chatting on here, our building is under construction as we install our new Watershed Discovery Center in our front room here. So if you hear any sawing or hammering, I apologize as we finish up our construction here. If you have a question, please use the Q&A function at the bottom, not the chat function. It's the Q&A function, and we will answer all your questions at the end of the presentation. If we don't get to your questions due to time constraints, we will follow up with you individually, or you are welcome to contact us at the Watershed Council. You can find all of our emails on our website. Lastly, this webinar is being recorded, and we will have it available on our Facebook page and our website. There'll be a survey at the end of today's presentation, and we really would appreciate your feedback so that we can improve these lecture series year after year. As always, virtual technology can go wrong, so if we have any technical difficulties, we appreciate your patience and graciousness as we work out any glitches. And next, lastly, I'm so thrilled to introduce our speaker. We're so lucky to have him here. Bryan Burroughs, the Executive Director at Michigan Trout Unlimited, who's going to be discussing a really impassioned topic today, climate change, a global issue, and he's going to be focusing on the local impact with us today. So thank you so much, Bryan. I will turn it over to you, and I'm going to stop sharing my screen, and you can share yours.
All right. Can everybody, can you see the presentation? Andrea?
Yes, you're good.
All right. Excellent. Perfect. Thank you. All right. Well, welcome everyone. I appreciate the opportunity to be asked to present on an important subject, especially to cold water fisheries in Michigan. And I am Bryan Burroughs. I've been with Michigan Trout Unlimited for over 16 years now. So I was just scrolling through the attendees list and recognized a lot of familiar names and faces in there. So thanks for joining today. I am going to talk about climate change specifically related to cold water fisheries and streams. And while it is going to be a focus on kind of a global issue with local impacts, kind of the subtitle here is it's predictable but unanticipated ways our weather is already reshaping our streams and their fisheries. So to kind of dig in, I'll start out with like a really high level of how I personally have changed my thinking about the local impacts from climate change. over the last decade or so. So, maybe 10 years ago, obviously climate change was a high level concern and a discussion point amongst Trout Unlimited members working on cold water fish. And it was really at that point a pretty simple premise and kind of a looming threat in that, as average air temperatures warm through time, and we're predicted to continue doing that and well out past our lifetimes, it would bring forth warming of water temperatures and therefore cause problems to cold water fisheries. And to some degree, that's begun occurring and is still looming out in front of us. But what we didn't have our eyes on, or I didn't have my eyes on, was just how many different ways climate change was going to act much quicker through a variety of means to cause problems and to cause changes to our cold water fisheries. And now that we've started to experience many of those, they're a little bit more understandable and predictable in hindsight, but we really didn't anticipate them a long time ago. And they are already emerged. They've been happening. People have been noticing them more and more and more. And I expect that that's going to continue to develop into the future. So in a lot of ways, what I'll share with you today is hopefully a better understanding of all these different mechanisms that are already upon us today. So some of the very basics of our changing weather kind of start with a real kind of basic level of how we're experiencing different changes. The image in the upper right is kind of the top part of our Earth's hemisphere, and there's been some warming and a weakening of the polar vortex, which basically means when we had really cold air temperatures in the Arctic, it helped balance out warm air to the south. And as that's weakened a little bit, it's caused the jet stream in our part of the hemisphere to have a larger amount of amplitude. So if you kind of shift to looking at the image in the lower right, the red box is kind of where we're at, roughly, plus or minus the 45th parallel. And on the left side of that, traditionally, we had a jet stream that kind of was subtle, without a lot of amplitude. And what that might have meant was, with exceptions, we might have had 3 or 4 days of a mild warm front, followed by 3 or 4 days of a subtle shift to a cold front. And the fronts didn't last as long and weren't quite as contrasting between them. And now, as we've gotten warmer and this amplitude's grown, it allows cold air fronts to bring in colder air and even further south than they used to. And when they're replaced, they have warmer, hotter air extending further to the north. When those transition between each other, because the fronts have that high amplitude, we get a lot of heavier winds. We get conditions that can lead to some really heavy precipitation events. And I'd also just say that everybody on Earth is experiencing these changes in different ways, for certain, but we're at the right latitude to really have our own unique and strong experiences with these weather changes. Some of the ways that these manifest, yes, it's gradually warmer, but it's pretty hard for us to sense that due to the increased variability of our weather. So another way of saying it from a statistical standpoint is, where we live, it's pretty hard to notice a change in the average temperature, because what we're really strongly experiencing is the change in standard deviation of our weather. I mentioned, what used to maybe be 3 day long, 4 day long subtle shifts in fronts and weather. Now we're getting, often 5 to 8 day periods of really pronounced shifts with some strong changes in between those. Peak precipitation events, because these conditions are, more extreme, we're having the right opportunities to have some really large precipitation events, which leads to having the chance of more severe and more frequent flooding events, which we'll talk about how that affects rivers later on. Our winters now can be quite a bit different. and we'll talk about that more too. But some of our snow melt or snowpack melt timing and groundwater table dynamics are shifting. We can also, during the summer, when you think about cold water fish, we can get some longer, hotter periods, which do indeed push those stream water temperatures in some places into some really tough conditions for trout. And then a whole nother realm of weather changes, Great Lakes ice cover. So as it gradually gets warmer, we have less ice cover. And I think back about a decade ago for Michigan, a lot of people thought global warming is going to get really warm. But what a lot of you might have experienced was more snow than ever. And that was because without as much ice cover for as long of a period of the winter on the Great Lakes, it picks up more moisture and you end up getting more lake effect snow dumped on you. So it's kind of a perception issue when people expected winters to get easier. You can often have places where it feels like a tougher winter with more snow. This year was not one of those. So, cold water fishing in particular, the ones that live in streams and watersheds in Michigan are a really great canary in the coal mine for climate change. And there's a few reasons for that. With cold water fish, the very basic premise is that those species require pretty cold water temperatures and high dissolved oxygen levels, and those two things are related. Colder water can hold more dissolved oxygen. Another issue is that these fisheries, their abundances are really tightly linked to the suitability, quality, and the availability of habitat in streams. So any changes to the streams make the fish particularly sensitive. Streams are also a unique physical balance between water supply and sediment supply. So if a water supply changes in a watershed, the timing, the amount of it, it's going to lead to sediment transport dynamics changing. So you can get more sediment moving, or you can get it moving from places in a river that you haven't seen it move and piling up in other places. And that's just because of the physical balance that rivers work on. Also, compared to lakes and streams are relatively shallow. They're pretty open to the environment, both a lot of edge effect, more prone to air temperature influence on the shallower water. And so stream systems are a bit heavier influence from what we call abiotic factors. So taken together, it's no surprise that these systems are going to be one of the first type of ecological systems that show some of these responses to changes in our weather. Shifting now to sharing with you some of the ways that we can expect and that we are seeing our rivers change due to the climate change and changing weather. The first is, what I mentioned and what's on all of our mind this winter in particular. So selling you this slide should be easier than ever, given this February. But that is snow melt and snowpack accumulation and when it melts. And traditionally, in what we think of as the old days with a nice long cold persistent winter, that precipitation in the form of snow builds up. It compacts, it freezes, you get more snow, it compacts. So you're sort of storing up the amount of precipitation over several months into snowpack. And then when things finally got warmer, southern Michigan, it might have been the second half of March, traditionally sometime in April in northern Michigan, that all of that snowpack would begin to melt. Now, certainly in some watersheds, a lot of that would go to the river as runoff. You'd see rivers that were pretty high and flooded or running dirty. But a lot of that also went into the ground and helped during that month of April leading up to May result in some of our highest water tables of the year. And so as we started progressing through May, June, July, and August, and July and August being our hottest months, you'd start going into those with a really high, fully recharged groundwater system with a high water table that would start contributing a lot of groundwater to our streams. And that would diminish throughout the season, but it started at a point in May where it was at its highest levels. And so as it dropped, it was in good shape with good volume, good recharge to still provide a robust amount of base flow to our streams come July or August. Now that we've shifted to more milder winters, we are seeing the new normal be we get snow events, we'll get a couple weeks of cold weather, you get some snow on the ground, and then we're going through a period in, December even, where all of that melts or a large portion of it melts. You might go through another cold part of January, get some more snow on the ground and see that melt again. And February's been the same. So what that means is that there's different dynamics now. We're not really kind of topping off our water table kind of late into the spring and then riding that through the summer. We can have situations where we enter the early spring period with a relatively low water table. And I think about 2 years ago was a good example of that, where pretty much by the beginning of May, we were getting reports of concern with a lot of streams in West Michigan from south to the north part of it that were already at very, very low levels, basically on par with some of the lowest base flow that we've seen in July and August, but it was starting out at the beginning of May. So this is definitely a concern for how our rivers function and how cold water fisheries make it through the toughest part of the year in the summer. Another really fun topic that could probably go for hours is just this concept that rivers are they are a physical balance, or maybe I should say like a physics balance, almost mathematical balance between water and sediment in a river system. And there's an equation down towards the bottom that's Q equal W times D times V. It's basically saying, the volume of water in a river is equal to the width of it, the depth of it, multiplied by the velocity of it. And you can move that equation around so that if you get more water in the river, things have to change, either the width, depth, or the velocity of it. And so the image to the lower left is a very popular kind of long-held depiction of how changing one aspect of a river results in changes to other aspects. And then the larger image to the right of the screen is another sort of mathematical concept about how things are related. And I'll explain that one for a minute and say higher flood levels do a lot more work or move a lot more sediment in a river than normal flow conditions. And so if you start having more frequent and more severe high flow levels, the river will do and move more sediment, and it will start shifting its shape. And so that's just to be expected. It's not kind of speculation, it's just how the math works. And so as we're seeing that happen, we are getting a lot more calls, and people will notice that sand has started to move and pile up in a particular reach or river that hasn't been noticed by people, using that river for decades and decades. And that is, again, probably a difficult scenario to mathematically explain or to use data on any particular reach of river to exactly explain why it's happened there. But it's really to be expected as our water supply changes, or what we call the flow regime changes. We should expect changes in the physical makeup of a river. And of course, the physical makeup of a river is what determines its suitability for fisheries habitat. Another key aspect with river changes that's kind of complicated by the way that we're experiencing climate change is the increased variability. And I've mentioned that already, just in kind of how we experience the weather. But for a river trying to make an adjustment to a change in conditions, it complicates it even more, in the sense that, not only is there a lot of variability within a year, there's variability between years that's pretty large now. And so think about a river mathematically that is just simply trying to adjust to consistently having a little bit more water flow. If it had that, it would make an adjustment, expand the channel in a channel shape in a certain way, and it would be good to go, and it would be stable again to the new condition. But in reality, it's a bit more complex as it relates to fish habitat, because you can have, very commonly now, a year where we have some really large floods, and the river may widen itself and change itself to accommodate those really high flows. But then the next year we might have atypical low flows and almost drought-like conditions, and then you would have less water flowing in a channel that just increased its size to handle more water. So it really kind of complicates the changes to the river and how the fish experience it for fish habitat. Another realm of river changes that is one that I would say we probably know the least amount and can explain the least amount about today has to do with the nutrients and the chemistry of the water. So when a river receives water either by runoff, overland runoff, shallow aquifers, or deep aquifers, the chemistry, the nutrients and different chemicals in those sources of water are different. And so as the supply, the quantity, or the timing of those proportions of where a river gets its water throughout the year can be expected to be shifting, it can mean that the water chemistry changes and changes at different times. That's really important of a concept because when you think about some of our nutrients, nitrogen, phosphorus in particular, phosphorus seems to be the most commonly the limiting growth factor for algae in freshwater systems. If we start seeing different changes in phosphorus, the algal community responds. There's certain species that deal really well with low phosphorus. There's ones that deal well with moderate and high levels. And they really form the basis of our food webs. And so if we start shifting algal communities, we can see changes in higher up trophic levels like aquatic insects or fish. And, this even has ties to some of the invasive species that we see like Didymo, where we still are trying to learn how some of these shifts in water chemistry may have made our rivers more suitable to those species. And we're trying to learn more about it so we can figure out what times of the year and what conditions lead to the right water chemistry for something like Didymo to have a massive bloom episode. So really important subjects. And unfortunately, the baseline data in Michigan for all of these water chemistry parameters, and there's so many of them that we could be interested in, is not great. And so if we're seeing some changes that suggest something, we can go in, try to collect enough water quality parameters to see what's going on, but we often lack any comparative baseline information to really be sure how it's changed. So I'll shift and now talk a little bit about how, what are some of the ways that we can expect these changes to directly affect fish? First is that general one that I've been mentioning all along, summer air temperatures. If we start receiving some longer periods of hotter weather, that's going to increase water temperature to different amounts for different streams. We do have some streams that are really heavily dominated in groundwater, exceedingly cold, that won't have much of a change. But some of our most popular and kind of beloved cold water fisheries are closer to the line of what a trout can tolerate right now. So as we get some more of these periods that push some of our river systems into really kind of unsuitable conditions for cold water fish, we can expect in those events to have increased mortality on all of the age classes of trout that are present. A second way that we see fish respond is through some interesting quirks with severe winters. And the bright news is that we're not having all tougher winters or more severe winters. So and this might be one way that overall we may see some benefits to trout, but we do know that we still do occasionally get some very severe winters. Might have been about 5, 6, 7 years now since we had a really crushing pair of them in a row. But when we do, there's a lot of ice dynamics that can cause a lot of mortality to trout. You can either just have a period of the winter that the river's frozen over, but you can also, in a more damaging way, get frazzle or anchor ice that happens on the bottom of a river as well. I'll mention right now and then come back to it in the next slide, but there's a dynamic where when we have more high flood levels in the spring, it can lead to year class failures of trout. I'll explain that next. There's the alteration of physical habitat and how suitable and spread out it is for trout. Again, as our rivers change, sediment transport changes, we can expect physical changes, and whether or not those work out in favor of the cold water fish there or not is a little different for every site. And so they will be influenced by changes, direct changes in their physical habitat available in our rivers. The last category is the concept of degree days and the timing of that. Degree days are basically how many days and what the temperature gets to, what's the average temperature for that day. You see that used a lot in concepts of agriculture, and also a lot of aquatic insect scientists use degree days because it really is a great predictor of when a species of insects will hatch in a particular water body. So again, as we're getting weather shifts where, winters might be more mild, water temperatures are warmer. You could have a scenario even where, you get into a June and there's a week of really hot weather. That can cause shifts in when insects hatch. And again, kind of tying this back to a previous slide, that's a good function for them to sense that, hey, it's an earlier year. I can reproduce a little earlier and give my offspring an added advantage and some extra time next year. And that would work if our weather was consistent, but you could have insects that, hatch later or earlier one year, and then the following year is the exact opposite conditions. And that can cause some failures of aquatic insect reproduction. And through time, those can add up and we can see, declines in how we perceive different hatches and key mayflies, stoneflies, caddisflies to be abundant. So going back to the concept of peak spring flow levels and in trout abundance, there's great literature available in scientific studies from around the world that tie spring flow levels to the abundance of trout. And we are also lucky enough to have had some really good work done in Michigan specifically on this subject. And the hypothesis that's pretty well supported is that there's this critical period for brook and brown trout in the spring when they're just at that point of hatching from eggs that might be nestled down into gravel and they're emerging as fry. And that period is a critical period. And if large flow events occur right at that time, it can cause a tremendous amount of mortality on that year class of brown trout. And the way brown trout and brook trout populations work is that if you have a really weak year class, that's going to continue to carry forward. And so people are actually able to predict trout population dynamics pretty well by the strength and weaknesses of certain year classes carrying all the way through their period. So a specific example of how this may play out specifically is brown trout in particular have roughly about 6 year classes present in a trout population in one of our rivers. Now, if you get one of these high flow events at a particular vulnerable time, one out of about every 4 years, that would mean that you'd expect in your trout population, one out of about the 6 year classes present to be pretty weak compared to the others. And that would bring you down from what you might be able to support in that population. But we assume that you go out and measure that under these, 1 in 4 year bad flow in the spring events, and that lets you have about 500 trout per acre. If you start increasing that severity, but really the frequency of those high flow events, and you got all the way kind of to the lower line there where it was occurring every other year, then you'd expect about 3 out of the 6 year classes present in your population to be significantly weakened for, quite a bit of loss of trout population. And if you went back out and did an electrofishing survey the population under that frequency of spring flow events, you'd only expect about 335 trout per acre. So again, sometimes we can't, we don't have the data to always understand the changes that we can observe, but it's very common these days with trout population estimates being redone every couple of years to say, oh, the population went down, the density estimates are lower. And we all sort of scratch our head and say, I wonder why, but it's important, at least if we're not going to be able to, have all the resources to document exactly why a trout population went down in a particular place, it's important to keep in mind that we do expect some of this to happen. I've already sort of mentioned this, but in hindsight, you can look back and you can see how weather changes, how the variability adds up, and you can kind of, make good sense of what you expect to see. Um, but we weren't necessarily expecting it. And over the last 5, maybe 10 years, but certainly over the last 5, the amount of river users, avid trout anglers who call with concerns over a particular stretch of river changing in ways that they haven't seen has really been going through the roof. The first couple times, those conversations stood out to me, and now they're, maybe not weekly, but several times a month. I get these calls from people who've, deeply and intimately known a section of river for 30 or 40 years, and they're saying that it's changed in ways that they've never seen before. It does make it hard that we often don't have all the baseline data to really go in and know exactly what happened and to what degree. But these are occurring. They're increasing in the amount of times that people observe them and notice them happening, and we can understand some of the mechanisms that cause them. So we'll shift. I don't want to be all doom and gloom. I think I might have only given one example of how maybe the changes in weather might benefit trout, and there were certainly lopsided to the ways that we're concerned that it may hurt them. And climate change is a tough issue, right? It's we know that the root cause and the primary solution to it will be on the global level with carbon emissions. And we all certainly can take steps personally to do our part in fixing the global problem and solution. However, it can be, kind of deflating and sometimes frustrating to know whether you can have a real impact at the global level. And so what Trout Unlimited does, and what we tell, anybody who loves these natural resources, is that there is a heck of a lot of things that we can do locally to take care of, in this case, the cold water fish that we love. We don't want to lose them. And we're not willing to kind of just accept a bleak future in that regard. There's a ton of things that we can do. So I'm going to walk you through a few of those now and explain just how powerful they can actually be. Dam removals is my number one. It's my number one tool to help cold water fisheries in the face of climate change for 3 reasons. It does 3 positive things. Number one, it changes a lake habitat inside of a river system back to river habitat. So you actually do restore oftentimes, a mile or 2 of good river habitat. Second reason is that it restores connectivity or fish passage in a river system. And I'll talk a little bit more about that in a second, but it allows fish to swim to different parts of the watershed that have different habitat quality, whether it's thermal refuges, spawning, overwinter survival. It allows fish to get to all of those different places. The third and most powerful thing that dam removals do is it alleviates water temperature warming. In the state of Michigan, we are generally flat topography relative to a lot of the country. And the way our dams were built, they're mostly small and medium sized dams, and they typically all warm up the water, either subtly or significantly, but they're all kind of taking water that should be flowing down a system, gaining some groundwater here and there, and they hold them in a pool or a reservoir for a certain amount of time where they're exposed to more air temperature and solar radiation. And I'll show you a little bit of just how powerful that warming effect can be in the next slide. But we can also actually fix water temperatures and improve those conditions through dam removal. And the task right now is, I have no doubt in telling you all of this, that over the last few years, you feel like you've heard more and more and more about dam removals and dam removals occurring and discussions about them. And that's true. But I will leave you with the fact that we're nowhere close to doing dam removals as much as we should and talking about them as much as we should. There is well over 3,000 dams in the state of Michigan. And so right now we've been on a track in Michigan of averaging somewhere between 2 and 5 dam removals per year. And I'm pretty hopeful through the work of a lot of different partners and entities that in the next year or two, we might even get years where we're hitting 8 or 10. but it would take us removing 30 dams per year, every single year for 30 years to address only about 30% of the dams that we have. So we have a lot of work to do to streamline and get quicker with dam removals, but there's huge benefits of doing them. So this slide is a little bit of a more tangible explanation of just how strong dam removals can be for dealing with these issues. And the photo is really just of a small privately owned dam and reservoir on a very small creek. We went in and we put a orchard logger upstream from the reservoir. There was one place down immediately downstream of the dam, and we compared those temperatures. But then the little creek that the dam was on very quickly, just 100 yards or so downstream of the dam, joined another larger river or creek. And so we also put a water temperature logger just upstream from the confluence and just downstream from the confluence. And the chart in the upper right shows you the difference in how the water was warming because of the dam. The yellow orangey line is the change in water temperature due to the dam from upstream from the reservoir to just below the dam and the tiny creek that it was sitting on. And this chart is really just from June 1 till the end of August. So you can see even kind of during the beginning of summer, there was maybe around a 6 to 7 degree warming effect from this dam, which, if you're wondering, was really only about 2 or 3 feet tall. But then later in the summer, that creek upstream went to 100% groundwater, and the temperature was really actually hovered around 55 to 60 degrees, even in the heat of summer. But with the warming effect of the dam, it went way up, and you can see that at times it went over 20 degrees Fahrenheit warming effect. Through the course of the whole summer, it averaged at 13-degree warming effect. Looking at the purple line, this is how much sending that warmer water into the next creek affected it. And you can see there that, occasionally it had a huge warming effect, but over the course of the summer, it was still warming the next creek down by, I think it was roughly about 3 degrees Fahrenheit. This dam removal project was relatively simple, only cost all said and done, maybe $35,000 to $40,000. And we gained back 13 degrees of temperature warming. So when you think about 100 years of air temperature warming predictions with climate change, and your ability to kind of repair a warming effect that we already have, and you think about the thousands of them that we have, it paints a really powerful picture that if we focus on dam removals, we may be able to give more immediate positive benefit to cold water fisheries than the amount of added stress from climate change coming for quite some time. Really powerful tool. Road stream crossing replacements are another powerful tool that we have. These are just a couple images at different scales, different sections of Michigan to show how many places we have road culverts or bridges crossing streams. And it's just important to know that a lot of those were done as cheaply as possible and were undersized, and they prevent fish from migrating up and down watersheds. And I mentioned it earlier, but fish can swim if you let them. And so if you don't let them, whatever section of a stream or watershed they're trapped in has to have everything that they need for all phases of their life at different times of the year under different conditions. And typically small stretches of river don't. And so you have a lower population level. But if you allow fish to get around and swim, they can find a cold water creek that's good refuge in the summer. They can find an optimal spawning area, and they can actually get to places in the winter that are more favorable. So this is why, trying to restore the connectivity of our watersheds is also a really powerful tool. A couple other tools that we have available and should stay focused on is in-stream fish habitat restoration or stream enhancement or adjustments. As I mentioned earlier, we can expect rivers to change. One of the complicating factors is in Michigan, we still have river channels that are not in optimal shape today because of past disturbances that we've done to our watersheds. And so we're not always in perfect health today. And with changes and adjustments coming, we often engage in practices where we try to improve that stream habitat. Sometimes it can be for wildly different purposes, but more and more so what we're doing is we're focusing those efforts that make making very purposeful and strategic adjustments to the stream shape in different places for different reasons, just to help it adjust itself to its new situation and what we expect to come. Another incredibly valuable role and a need that we have in Michigan to address this problem is data collection. Most resource professionals, agency employees, NGO employees have limited resources and limited time to go and collect the data that we really need to understand how we're doing and what different sections of stream needs from us. We have over 30,000 miles of cold water streams in Michigan. That's more miles than the circumference of the earth. And so just the basic knowledge of what is the status of these, and you could take any one tributary anywhere around where you live and say, we'd like fisheries data, we'd like stream physics or habitat data, we'd like water chemistry data, we'd like water temperature data. And the cost and the time involved in getting that for any one particular place is pretty daunting. And I think the real future to all of us doing a better job taking care of these resources is really going to be tapping into citizens to help support that data collection. And then lastly, in Michigan, groundwater is the reason we have cold water fish. There's a few examples in the very northern parts of the UP where it's probably just a predominant colder air temperatures that allow a stream to have cold water fish. But by and large, Michigan has cold water fish and incredible resources because of groundwater. And in the future, there's going to be more and more demands on that. And we already know that the nature of groundwater itself and our water tables will probably start changing. So we need to be focused on investing in groundwater science and management and regulations to help protect those resources. As weather changes, I know most of the audience here live in northern Michigan, and that's a lot different situation than southern Michigan, where irrigated agriculture is really already very, very abundant. You don't have it, but again, as weather changes, agriculture and other types of groundwater use demands are extending northward. You might have started seeing some, and you should expect more in the coming decade or two. So kind of, one last answer to what you can do locally. This bottom yellow line is what I believe our cold water fisheries and our streams currently are at. We're at a lower level of health than where our potential is because we have so many legacy issues that we have not yet addressed. And the science on, the health of a system handling new stressors is that if you're at a lower compromised health level and a new stress occurs, you can expect a decline, followed by some level of stabilization, and then further decline with new stressors. When you have a system that is really at its full potential of health, often they can handle a new stressor, maybe decline, but then rebound. And so I think one of the key answers here in front of us is really getting our rivers caught up and as healthy as they can so they can handle these new stressors that we will continue to learn about. So I will just conclude by, maybe sharing with you kind of the perspective of Abraham Lincoln when he said the best way to predict the future is to create it. And in this context, we will only ever be so good at predicting what's coming our way. But if we stay focused on creating the places that we want to have, we might just shape the future in that direction. So that's it. Thank you very much.
Well, thank you so much, Bryan. That's very poignant to end that way. I don't know how to even feel after listening to your presentation. Some incredible, insightful information. So thank you very much. We're so lucky to have you in our community. Thank you. We do have a few questions, and construction's kind of started up a little bit on the wall next to me. So if it gets a little loud over there, I might ask Jennifer McKay, who's here online with us, to pop on and ask questions so it's not distracting. But just to start, and you talked a little bit about fish in your presentation, but someone specifically had a question about reproductive concerns of lake whitefish in this area.
Sure. I know the general information about that. I'm not a specialist on Great Lakes fish, so I'll be careful not to go too far. There are concerns with fish like whitefish where, as I understand, their spawning does require or is linked to ice cover in some ways. And I've also heard that they often spawn on some very shallow reefs where light penetration and so UV wavelengths penetrating can cause some mortality and failures. So I'm generally aware that even though the Great Lakes are a larger water system than streams, that even with a fish that we think of as a pretty deep water species, that there's some concerns because of these climate changes that are happening. But I'm not the expert on that species or that water body.
Yeah, I'm wondering if Dennis, who asked that question, maybe was listening to NPR this morning as well. I was listening to that. They were talking about whitefish. So, um, next question. And this person might want to join us in 2 weeks for our presentation from Jeremy Wood about beavers. But he had a question about how do beavers play a role in climate change and water retention? Is it true that beaver dam creation helps store water on the landscape? And with warmer temperatures, wouldn't it be beneficial to keep beaver dams in many of our cold water systems to help sustain groundwater input and reduce peak flows?
Sure, that's a wonderful question. And I think I have a pretty good, concise answer, but just know that there are large conferences that spend days talking about beavers and trout streams, and they do both things. They have some positive benefits and some negative benefits. And in Michigan, we often struggle because a lot of the studies about the benefits of beaver dams occur either in the Rocky Mountains or out east in the Appalachian Mountain Range, and in a setting where those streams are more runoff dominated and they're very high gradient. And in those systems, it is pretty clear that beaver dams really typically serve more benefits to trout streams than detriments. The real quirk is for us here in Michigan is that we're so low gradient and we already have great groundwater recharge because we're in a very sandy geologic setting. And so beaver dams, they may still help to store. Basically, when they create a dam behind them, it's taking some of the high flow events, pushing them into a wetland to help recharge the aquifer, so they can stabilize some of the flashiness of a stream from some of the high flow events. That's true. I think the context of Michigan, however, is one where we're already having a lot of that storage, and we have our country's most stable trout streams. And so balancing the kind of the possible water retention benefits of beavers, which are possible, but probably the likelihood is a little lower here in Michigan. And then the concerns that we often have with beavers on trout streams is that it may not be one beaver dam, but you often get colonies of beavers in a section of a watershed where there's not a lot of people. They build up for a decade and they make numerous dams, sometimes 10, 12 dams in a river mile. If each one of those warms the water temperature by a half a degree, you can have a scenario where your stream is warming 4 or 5 degrees from a collection of beaver dams. And if that stream was, say, running at a July mean water temperature of 69 degrees, and those collection of beaver dams pushes it to 72, you'll go from possibly 300 brown trout or brook trout per acre down to, probably 10 per acre. So it's really kind of, I don't think that there's a right answer. I'm not going to profess to kind of, have a right answer on how to balance beavers, but just know that the context of Michigan is really different than a lot of other parts of the country where we've learned about really strong benefits from beaver dams. I think it's more nuanced, balanced job here.
Okay, and again, if you don't have the answers to these questions, we can follow up with these individuals afterwards. But Richard Hayes asks if you know how do microfibers add to these changes, if any?
That's a good question. I would say when I think about it, right or wrong, I think the microfibers pose their own unique set of challenges to some of our fisheries and in particular Great Lakes. But I think for now, I don't think I tie the problems posed by those so tightly to kind of, some of the other challenges that I spoke about today with streams and climate change.
Okay, next, Herm always joins us with some good questions. Is the initiative to reintroduce grayling to Michigan rivers counterintuitive to the trend in stream temperatures?
Um, using the term counterintuitive, it may be. It may be. Uh, Overall, grayling, pose a pretty tricky challenge to restoration. They're also one of our cold water fish that have like a fairly demanding portfolio of needs. And knowing that some of those challenges are already getting tougher, I think it's a fair question of whether kind of picking one of the most sensitive out of a sensitive group is really the right strategy. I think that's a fair discussion point. I think, I think the folks that are leading the grayling restoration initiative are hoping, and I think they're thinking about it in the right way, in that out of those 30,000 miles of trout streams we have, there are still places that are amply cold, that are predicted, to be amply cold for a long time. I think they're really just looking to find a small collection of places that grayling can make a home again. And I don't think any of them would necessarily think that grayling are going to once again become, the most abundant or dominant cold water fish in our systems.
Thank you. With some cold water fish unable to tolerate higher temperatures, do you foresee stocking of different native, and I'm hoping I'm saying this right, so I don't get made fun of by my coworkers later, salmonids, moving away from arguably invasive brown trout fisheries and focusing more on brook trout and Arctic grayling?
Great question. Kind of tangled up to answer that. And the reason I say that is, it's actually the brown trout, who is not technically native, but it's been here, in Michigan for more generations than, most of our families have been. It's the brown trout that actually have the highest thermal tolerance out of most of the cold water fish. And so that's why that subject of native versus wild becomes important. We don't want to lose the native fish like brook trout in particular. And but we know with the coming challenges of warming conditions that they're going to probably have a home in some of the coldest of those, the most intact groundwater systems that remain the coldest. And I think it's actually the brown trout with its higher thermal tolerance that, we actually have to be thinking about. If there's one of our cold water fish that has the tolerance to handle what's coming, it's more likely to be the brown trout. But we still want to balance between kind of native and wild, and have a portfolio that has a place for all of those.
Okay. Excuse me. Richard is asking if you have any information or commenting on Nestle's draw on water to create bottled water and the impacts of
Um,
it.
I don't have wonderful, useful information on that. I believe that when Nestle sold Ice Mountain to a different company, I recall about maybe a year or two ago that the new company was not pursuing some of the same level withdrawals that they had sought under Nestle's. And so since that time, I'm not sure I've heard a lot about the pursuit of any additional water withdrawals from Ice Mountain under the new owners.
Okay, Alfred wants to know, he said you described the benefits of dam removal, but apparently at some point they were installed for a positive reason. What are the trade-offs of removal of these dams?
Well, there will be different trade-offs, and that is, why the discussion over dam removals kind of takes a different path at each particular site. It is true that dams were built, obviously, for some reason in the past. Somebody had a reason that they wanted the benefits of it and was willing to pay the cost to build it there. Some dams still have pretty strong benefits in place. But since it's been, really about 100 years since the peak of dam building in this state, a lot of those original benefits are long past. One of the dams that I studied in graduate school was one that was originally built by Consumers Energy in hopes that it would power a small electric railroad between Manistee and Cadillac. And about 15 years after they built it, the river completely filled in with sand and rendered the little hydroelectric operation moot. Hydroelectric is really no longer financially beneficial compared to other renewable energies like solar and wind. So we're seeing even hydro dams, which, on their face probably have the best benefit proposition. It's kind of clear what they're doing and why we had them. A lot of other dams were recreational. A family might have built it for, a water supply in case of a fire or a place to swim. And so as they get old, some of them, most of them fill in with sediment. The one I showed you a picture of, I mean, that was a small recreational pond, and I think the family loved boating and swimming on it, but then it became, 1 or 2 feet deep with black muck everywhere. And so that purpose kind of set sail and was lost a while ago. So in each case, it's very, very much that's how dam removals proceed. The owners of them think about the values they have, how much it will cost to maintain them and keep them safe. And people who, love rivers and say, well, hey, this dam's doing this and we could have this if it were removed. You conversate about it and you try to figure out what that trade-off balance is.
Okay, and lastly, it looks like we've got one last question from Mike Foley. First, he thanks you so much. He likes the idea of local solutions, heavily supported with community science-led data gathering. We love to gather our data here. What physical measurements would you put the highest priority on for data gathering in our local streams to establish those useful baseline data, either by professionals or community scientists?
Ooh, it's like one of my favorite subjects, and we are constantly having those discussions in different watersheds in Michigan for different purposes. So I'm not sure I can tell you one universal answer. What we usually do without spending too long on it is we will take a look at the watershed and any available data or insight that we can already gather. So predictions of water temperature, stuff from the Eagle database when they did an aquatic insect index, and we'll use whatever is available to tell us as much as possible. And then we kind of start dropping in and saying, okay, we don't have water temperature in these places. That's step number one. It may be fisheries data. Hey, we really need to know how abundant they are, if there's mortality issues apparent. And increasingly, we also choose water chemistry stuff to understand some really weird changes, like the Manistee River or the Boardman River with Didymo. We have proposals out now to go pretty heavy into a barrage of water quality parameters. So it's a little different in every case, because we never can afford to collect all of what we want everywhere that we want it. We kind of suit it to each individual watershed and what we know about it. Great question.
And just lastly, you got a nice little shout out from Kaz, who I think is Brian Kosminski, I'm going to guess.
Yeah. Thanks,
Just
guys.
thanking you for your time and knowledge, Dr. Burroughs.
And Brian does actually have a question that he snuck in there, which is saying many studies are showing that brook trout are not native to the Lower Peninsula, which he finds hard to believe. But what is the difference between native and wild or naturalized?
The quick answer, because I think Kaz probably knows I could spend an hour or so on that. The quick answer is wild and naturalized are pretty similar terms used around here. Native is something that somebody can prove was present at some point in the past. Most people choose like pre-European settlement. It could be any point in the past. I mean, there was a time before certain glaciers that things weren't here. So it's a little abstract, but usually native is present pre-European settlement, and wild and naturalized are the both terms for something that wasn't here very long and has since become self-sustaining.
Thank you. And thank you again, Brian. You're just an incredible resource for us. Thank you so much.
That was my pleasure. Thank you all.
And if you have any questions, I'm sure you can reach out to Brian individually or anyone here at the Watershed Council. I'm going to quickly share my screen, hopefully, for a closing today. Hoping you can see it. Just wanted to let you know about our next lectures coming up. We have on March 7th, more questions about beavers will be answered. All about beavers, their impact on our ecosystem, and why you should give a damn, with Jeremy Wood. And then March 21st is our final lecture. We'll be talking with Tom Nordone, who's a friend of mine from downstate. He's talking about trash fishing, a new way to reel in the catch of the day talking on some programs he started in Lower Michigan on how to clean up rivers and lakes in your area. So we'll see you for those presentations. And of course, we always need volunteers. If you want to join volunteer lake monitoring or stream monitoring programs, please reach out to us. We would be glad to have you. And lastly, of course, consider becoming a member. Memberships support everything we do here. We can't appreciate thank you for your support enough. So consider joining a member and helping us provide these services all year long. So thanks again, Bryan. We'll catch everyone in a couple weeks and enjoy the rest of your day.